Good morning all. My name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is Computer Architecture. Today I am discussing about problem solving on binary codes. So what is binary code? A binary code describes a number of schemes in which there are only two possible values of each digit, 0 or 1, and is the basis for all binary code used in computing systems. These systems use this code to understand operational instructions and user input and to present a relevant output to the user. The term binary also refers to any digital encoded decoding system in which there are exactly two possible states. In digital data memory, storage, processing, and communications, the 0 and 1 values are sometimes called low and high respectively. So, in the binary code, the binary is nothing but 0 or 1. These are called binary codes. So, there are two binary codes 0 and 1. Suppose I'm taking 110, 110, 11. Is it 8-bit binary code? Is it 8-bit binary code? So it is describes the number of schemes in which there are only two possible values, that is 0 or 1 in the basis binary code, and these systems use this code to understand operational instructions and user input output to present a relevant to the user. So operational instructions means if I have to go for any arithmetic operation, any logical operation, so system understanding or machine understanding language is a binary code. So what you can write, if you are writing any of the code, that will be converting. Suppose I am writing any high level language, so it is converting to the machine language. That is called binary code. So any of the code it is converting to the finally it is converting to the binary code. And the term binary also refers to any digital encoding decoding system in which there are exactly two possible states. In digital data memory, storage, processing, and communication, the 0 and 1 values are sometimes called low and high respectively. Suppose if I am taking 0, that is low, I am taking 1, that is high. Okay, low and high, that will be depending on your binary code 0 or 1. So if I am using my binary code with the help of 0 and 1 form in the binary code, so low and high I will be referring to the binary code. So binary code 110 11101. So it is a binary code. It is 8-bit. But any of the 8-bit or 60-bit, any of the set of binary numbers, that is called binary code. So high, low, like this. High means 1, low equal to 0. Off means 0. On means 1. So I will be describe high and low in the form of binary only, and off on state also will be referring in binary form only. And what are the classification of binary codes? There are so many types of binary codes are there: weighted code, non-weighted code, reflective code, sequential code, alphanumeric code, error detecting and correcting codes. So there are 6 types of binary codes are there. So weighted codes means we have to give some weight. 8421 method example. So weighted code means 2 power 0, 2 power 1, 2 square, 2 cube, like this. Suppose I have 1101. So what is the weight of this one? 2 power 0, 2 power 1, 2 square, 2 cube. That means 8, 4, 2, 1. So proper weight we are giving to the code. That is a weighted code. And the non-weighted code means there is not a proper weight. 8441 example. Is it weight properly? No, it is not a proper weight. 8221. It is not a proper weight. So it is also called non-weighted code. Reflective code means we are converting from one code to another code, like this. And sequential means we are sequencing the code. Alphanumeric means we are giving only alpha and numeric numbers. Error detecting correcting means suppose I have one code 11011. So maybe this code is error maybe. So how can we find out? So I'm using some error detection and correcting methods. Use some methods to find error detection and correction. So error detection and correction. So these are the two types are there. So error detecting means where is the error we have to find, and error correcting means what is the exact value in place of error. Suppose example, this is a error. In place of 0, the 1 is generated. So I was detected that this code is error. I was detected that this code is error. But where is the exact error? So we have to find out and we have to correct. That is the error detection and correcting codes. So these are about the binary codes. So 8421 method I am taking example 1101 240 241 2 square 2 cube. Example 547. So what is the value of this one? 840 8 power 1 8 square. So that is the 64 8 1 like this. So how we are finding out 8421 method? If I am taking 8221, so it is a not a proper weight. So we will discuss later what are the weighted codes and what are the non-weighted codes. Example weighted code. Each digit position of the number represents a specific weight. 8421, 2421, 3321, 5211, 5311, 5421, 6311, 7421, 74 minus 2 minus 1, 84 minus 2 minus 1. So minus, why I am getting minus 1 means, suppose like this, fractional values are there. Fractional values means maybe we are getting as a 2 power minus 1, 2 power minus 1, 2 power 2 minus 2 like this. Okay. So like this we are getting the negative values. That is the fractional values. So binary codes are two types. Binary in the form of binary and BCD. So weighted codes are two types. That is the binary code and BCD code. Weighted code. So these are the two types. First one is a binary code. Second one is a BCD code. BCD is nothing but a binary coded decimal. Binary coded decimal. Binary, and second one is a BCD. That means binary coded decimal. So these are the weighted and non-weighted codes. Suppose I am taking decimal number 0. What is the BCD? That is called 8421, and XS3 code 8421, 2421, 5211. Example. So like this 0 to 9. Suppose we have to take decimal number 9. What is the BCD value here? 1001, XS3 1100, all ones like this. Okay. So 240, 2 power 1, 2 square, 2 cube. So what is the value here? 2 cube into 1 plus 2 square into 0, 2 power 1 into 0 plus 2 power 0 into 1. So 2 cube equal to 8. 8 into 1 plus 0 plus 0 plus 1. How much value? 9. Like this. Okay. Here XS3 code means what is the value we are adding plus 3 to this one. That is the XS3 code. 8421 means what is the weight of this one. Okay. Like this. And 2421, 5211. All ones are there means, is it a 4 digit is there? Yes, it is a 4 digit with all values are weighted 1. That is a 1111 like this. So suppose we have to take 8. So what is the value means? 2 4 ja, 2 2 ja, 2 1 ja, 2 0 ja, 1. So what is the value? 1 000 base 2. How we got means 2 power 0, 2 power 1, 2 square, 2 cube like this. So 2 cube into 1, 8 plus all are zeros. So it is a 8. So from this we are getting like this. So it is a weighted code. And binary coded decimal number system, that is a BCD. Binary coded decimal, that is also called 8421 method. So binary coded decimal is encoding 10 digit from 0 to 9. Okay, we are taking from 0 to 9. That is a binary coded. And BCD is a weighted code. So already we discussed binary codes are two types, weighted code and non-weighted code. But here BCD is a weighted code. Why? Because weighted codes are two types. First one is a binary code, binary and the second one is a BCD, binary coded decimal, and the weights are 8421, and there are 6 invalid codes are there, 1010, 1011, like this. So these numbers we are converting from number system to BCD. Oh, what is the process? We'll discuss. Suppose I'm taking decimal number from 0 to 9. Example, decimal number is 0. What is a BCD value? 0000. 1 means 000, 1, 2, 0010, 3, 0011, 4, 011, 0100, 5, 0101, 6, 0110, 7, 0111, 8, 1000, 9, 100, 1. Example here I'm taking 0101, 2 power 0, 2 power 1, 2 square, 2 cube. 2 cube into 0, 8 into 0. 2 square means 4 into, here 2 cube into 0, 0. 2 square means 4 into 1, plus 2 power 1 means 2 into 0, plus 2 power 0 is equal to 1 into 1. 4 plus 0 plus 1. How much? 5. So 5 base 10. So the decimal numbers are from 0 to 9. We are converting to the BCD. It is a process. We are converting to the binary code of BCD. So next we are discussing example here. Example 1. Convert the number 13 into BCD. So 13 is there. Actually, what are the BCD numbers are there from 0 to 9. So the numbers are from 0 to 9. But here our value is 13. It is in the range? No, that is not in the range of 0 to 9. So 13, what we have to do? 1 I am taking separate, 3 I am taking separate. So what is the value of 1 here? 000, 1. What is the value of 3? 00, 11. So 000, 1, 00, 11 base BCD. So it is the 13 base 10. I am converting to the BCD. Why? Because the BCD is range from 0 to 9 only. But what is our input here? Our input is 13 base 10. We have to convert to BCD. So 13 is not in the range of BCD range. So that is the reason we are taking 1 is separate and 3 is separate. So some more examples we will discuss now. Suppose I am taking 25. So our BCD range is from 0 to 9 only. So what is a 2 and what is a 5? So what is a 2 value here? 0, 0, 1, 0, and here 0, 1, 0, 1. So 0, 0, 1, 0, 0, 1, 0, 1 base BCD. What is input now? 25 base 10. I converted to the BCD like this. Actually, what is our number system means? Suppose I want to convert to not BCD, I want to convert to binary. How we have to do means 25 base 10, we have to divide with like this. So 2 1 2, 2 2 2 6 2 3 2 1 2 2 0 1. What is the means? 1 1 0 1 base 2. It is called binary. It is a binary. So 25 base 10 I have converted to binary. What is the answer means? Here 25 base 10 converted to binary. 11001 base 2. It is a binary. But here I converted to 25 base 10 to the binary BCD. So how we are means 2, what is a 2 value in table and what is a 5 value? Here 2 value and here 5 value. So we are added both together. We are getting 25 base 10 is converted to the BCD. So binary code ABCD and BCD code, here the decimal number. So decimal numbers from 0 to 0 to 9, 0 0 0 0 0 0 1 like this. 111. After 111, what we are getting? 1 0 0 1 0 0 1. So after 10, what we have to do? Here, what is the value from BCD values from 0 to 9? BCD range is from 0 to 9. So after 10, what we have to do? After up to 0, the carry is 0. After 1, 0 to 9 range, after the 9 range, here I am taking as a, here the range is 1 I am taking. 0, 0, 0 is common, but here I am taking 1, 1, 1, 1. But here all are zeros, but here extra digit is the, here 1 I am taking here. Why? Because after 9 the range is like this. And binary code, it is in the form of 8421. So decimal number 0 to 9. So what is the range of this one? Suppose I am taking 4. So the 4 value is 0100. How we got? The 4 values here in the table 0100. How we got this value? That means 2 power 0, 2 power 1, 2 square, 2 cube. 2 cube is nothing but a 8, 4, 2, 1. So from this 8421, I got the value is 4 is nothing but a 0100. 9 value is 1001. How we got means from the BCD, from the 8421 method, BCD 8421 method. So it is a MSB and it is a LSB. 8421 method means leftmost value is MSB, rightmost value is LSB. MSB means most significant bit. Most significant. Most significant bit. And here least significant bit. See, least significant bit. So MSB and LSB. So XS3 code. XS3 code is a non-weighted code. Why? Because it is not a proper range. Suppose I am taking BCD 8421. It is the weighted code. Why? Because we have one weight is approved 8421, 2 per 0, 2 per 1, 2 square, 2 cube. We have some proper proof and proper valid is there. But here XS3 means after getting the BCD value, we are adding 3. So what is the resultant of BCD? For that resultant value, we are adding plus 3 for that one. That is called XS3. Suppose my value is 0, 0, 0, 0, 0, 0, 0, 0, 0. I am adding XS3. So in the binary code, what is the 3 value? 0, 0, 1, 1. Why? Because 2 per 0, 2 per 1, 2 square, 2 cube. It is 0 plus 0 plus 2 power 1 into 1 means 2 plus 1. How much? 3. So 0, 0, double 1. We are adding 0 plus 1, 1, 0 plus 1, 1, 0 plus 0, 0. So it is like this. Suppose I am taking here 5. What is the 5 value in BCD? 0, 1, 0, 1. We can check once, no problem. 0, 1, 0, 1. 2 power 0, 2 power 1, 2 square, 2 cube. 0 plus 2 square into 1, 2, 4 plus 0 plus 1, 4 plus 1, 5. So for 5 plus 3, what is the 8? 8 is nothing but here. In a binary code, what is the 8 value? 1, 0, 0. 2 power 0, 2 power 1, 2 square, 2 cube. 2 cube into 8, 1, 8. 0 are zeros. Okay. Like this, we will get. So it is a BCD and XS3 code. Suppose I am taking convert 13 into XS3 code. So what is the 13 value? XS3 code means step 1, convert to BCD. Step 2, add plus 3 to the resultant BCD. Step 1, convert to BCD, add plus 3 to the resultant BCD. That is called XS3. So first I want to convert to 1, 3. Converting to the, so what is a 1, 3 in the BCD? BCD range from 0 to 9. But here 1, 3 is there. So what is a 1, 3 means? 0, 0, 1. And what is the 3 value here? 0, 0, 1, 1. So 0, 0, 1, 0, 0, 1, 1. It is the BCD value. Okay. So this value 0, 0, 1, 0, 0, 1, 0. For this, we are adding plus 3 for this one. Okay. Here 0, 0, 0, 1, 0, 0, 1, 1. So we are adding plus 3, 0, 0, 1, 1. We are adding for this one. 1 plus 1, 10, 0 plus 1, 1 plus 1, 10, 11, 0 plus 0 plus 1, 0, 1, 0, 0, 0. So what is the value? And 0, 0, 1, 1. We are adding here. 1 plus 1, 10, 0, 1 plus 1, 10 plus 1, 11, 0 plus 0 plus 1, 1, 0. And here 1 plus 1, 10, 0 plus 1 plus 1, 10, 0 plus 0 plus 1, and 0. 0, 1, double 0, 0, double 1, 0. It is the accessory code. So we are converting from the number 13 to accessory code. First converted to BCD, after then converted to the accessory. Suppose I am taking 25, convert to accessory. So 25 means 0, 0, 1, 0, and 5 means 0, 1, 0, 1. Okay, so it is the BCD value. So it is the BCD. For BCD, we are adding plus 3. Plus 3 means 0, 0, 1, 1, 0, 0, 1, 1. We are adding plus 3. Excess 3. That means plus 3 we are adding to the BCD. So here 1 plus 1, 10. 0 plus 1 plus 1, 10. 1 plus 0 plus 1, 10. 0 plus 0 plus 1, 0 plus 1, 1, 1 plus 1, 10, 0 plus 0 plus 1, 0 plus 0. So 0, 1, 0, 1, 1, 1 plus 1, 10, 0 plus 1 plus 1, 10, 1 plus 0 plus 1. So like this. So it is the access 3 code. So this 25 base 10 we are converted to the accessory code. So binary arithmetic is an essential part of various digital systems, and we can add, subtract, multiple, divide in the binary numbers using various methods. And these operations are much easier than decimal number and arithmetic operations because the binary system has only 2 digits, that is 0 and 1. So when we are going for the binary, that is called base 2, and we are taking as a 0 and 1 system. And a binary number is built up same, we can build a normal of decimal number. And in the binary addition and subtraction are performed in the same way of decimal addition and subtraction. So add a 0 plus 0 and sum equal to 0 plus 0, and what is a carry, like this. So here it is a binary addition. So these are the binary addition numbers. So in the binary code, we're describing as a in the form of 0 and 1, and these are the relevant operations are there in the instruction, and we are taking for the on off state or encoding and decoding, and we are going for the low and high values for these. For this we are using binary codes. And what are the classifications of binary codes? Weighted code, non-weighted code, and reflective codes are there. Weighted code, non-weighted code, reflective codes, sequential codes, alphanumeric codes, error detecting and correcting codes. So these are the binary codes. So weighted code means proper weight we are applying to that. Non-weighted means there is no proper weight for that one. Reflective code means the binary code is reflective, means one code to another code we are converting. And a sequence of code, that is a sequential. Alpha and numeric codes are adding. And error detecting correcting means what is a binary code. If our binary code is anything problem, we can detect and correct that binary code. So there are so many types of binary codes are there, but binary codes are 2 types: binary in the form of binary and BCD, binary coded decimal. So weighted codes are 2 types: binary code and BCD code, binary coded decimal. So suppose I'm taking 25 base 10, convert to binary, and also convert to BCD. So what is the process? 25 I'm converting to the binary, first one. 2 6 ja, 2 3 ja, and 2 1 ja, 2 0 ja, 1. So what is the value now? 1 1 0 0 1 base 2. So 25 base 10 converted to binary means what is the value now? 1 1 0 0 1 base 2. So this I converted to binary. Next, this I want to convert to BCD. So BCD, what is the range of BCD? 0 to 9. But here 25 is there. So we have to take 2 values separate and 5 values separate. What is the 2 value here? 0, 0, 1, 0. What is the 5 value here means? 0, 1, 0, 1. So 0, 0, 1, 0, 0, 1, 0, 1. It is the BCD code. So binary code, in the weighted code, any of the weight were converted to the one form is binary, another form is BCD. So there are two types are there. Binary is one type and BCD is another type. Non-weighted codes means XS3 and gray code. So non-weighted codes are nothing but not assigned the weight to the digit position. And these are the two types, XS3 and gray code. Suppose any of the binary code from 0 to 9, we are taking binary code from all zeros to like this. XS3 means what is a binary code? We are adding plus 3 to this one. 0001 we are adding plus 3 and 0110 adding plus 3. So gray code means in the next class we'll discuss it is the reflective code. So binary coded decimal, that is a BCD. So BCD is nothing but the range is from 0 to 9 and it is a weighted code. The weight is nothing but 8421 and there are some invalid codes will be also there. So it is the decimal to BCD 60110 like this. Okay, it is from 0 to 9 range of BCD. Convert 13 into BCD. So what is the one value here in the from the table? 0001. And what is the 3 value? 0011. So we are adding all together, getting BCD. So it is a table binary code, decimal and BCD code. So binary code range from 0 to 15, but BCD range from 0 to 9. It is a 8421 BCD method. 8421 is nothing but it is a weighted code, that is a binary coded decimal. So 8th position is the leftmost is the most significant and the right side most first position is the least significant bit. So it is a XS3 code. We are adding XS3 and decimal number and binary BCD and we are adding XS3 means for the resultant BCD we are adding plus 3, that is called XS3. So 13 is there, convert to XS3. That means 13 we are converting to the binary BCD. After the getting the BCD we are adding plus 3 to that one, that is the XS3 code. So it is about the binary code. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.